Hi friends. The following video is from a stream that I did talking about different input methods for your game. We're going to talk about how to do keyboard, which is pretty simple, kind of table stakes. Then we'll move into pointers and kind of the issues with pointers. And then last up, we'll talk about doing gamepads. So the Gamepad API allows you to hook up things like this into your browser and get those working in your game, which is pretty cool. And then I want to talk about a coding pattern called input mapping that can help you improve the accessibility of your game. So let's get into it. Again, real big thanks to my sponsors. Hello, everybody. Hello. Welcome back to your Sunday stream on a Monday. I was too gassed yesterday to stream, but today we're going to talk about input for your games on the web. So what do I mean by input? I'm talking about like keyboard pointers such as like touch, mouse, that kind of thing. Then we're going to look at gamepads. So I have got a Xbox controller here. So we'll play with that a little bit later. And then talk about a little bit about input mapping and how that can save your bacon. So, all right, let's get into it. Input. What is it? What is input? Well, I guess it's anything that you can input into your game. So keyboard, pointer, gamepad, those kind of things. You'll notice if you watch the last stream, this will be very familiar. We're starting off with the same code that we played with last time with FPS, and we can go take a look at that here. Why don't I go ahead and start this code? And same old deal, it's running with Parcel, which is my favorite bundler. So here it is running our familiar robot here running around the screen. So what we want to do today is, wire this up to some input. So right now, if I press on the keyboard, nothing happens. If I click on here, nothing happens. And if I use Gamepad, nothing happens. So what I want to do is figure out how, in this game dev code, how do we, make use of this? How do we use input in your game to make it do things? So, when we were talking last stream about the main loop, which is, that infinite loop that runs every frame to, grab an update, and draw the screen, we'll want to, in that update, collect our inputs at that same time. So, in our update here, we're gonna handle our input. So for keyboards, we'll want to listen for key events, and then take those key events and then do something with them in our game. So how might we do that? So I'm going to do, I'm going to make a class here to grab all the keyboard events. I'm just going to call it keyboard. And one thing that we do in the browser to listen for key events is you can listen on the document. You can listen on anything that has focus. But one thing that we're going to do is there's a few different bits and bobs on the key event. And there's really only one code that you usually want to use, but you can use the others. Using this specific code, the event.code, works cross browser. There's differences if you use the integer code for a key. So we want to use the event.code. So I'm going to go ahead and new this up. We're going to listen to the document for key down. On key down, we're going to get a key event. And then one thing that I do to make things easier to work with in keys is I like to keep track of all of the keys that are down in a key vector. And that's just a fancy word for a list. So I'll just make keys. It's going to just be a string array, string list, and that'll be our key vector. So then we can go insert. When we have an event, we can go and insert our key code into the key vector. Now I want to go look at this key code with you. Keyboard event on MDN. So let's go take a look at that real quick and just understand it a little bit. So let's go to code. So this is the one I like to use. It maps to the physical key on the keyboard. And you get a nice little string about what key it is. So you got like key Q or key A. Versus like looking at key, you'll get, let's see, is it key that I'm thinking of? Or char code or key code. You'll get a number, and this can be different depending on your browser, which can really throw you. There's a lot of warnings in here. So, and in fact, there's this table that gives you a lot of confidence that you're going to be real sad if you use anything but like the key code. So I recommend using key code for your games. And this maps to like the physical key on your keyboard, and you'll be much happier, trust me. So we're going to use that in our key vector here. What I don't want to do here is if I have multiple key downs for a particular key, I don't want to like keep adding the same key to this vector. So I only want to add it if it's not already there. So I'm going to go look for it real quick in the key vector. So index of event.code. So we're going to go look for it. So this function gives us the index in the list of anything that matches this code. And if it doesn't match it, it'll return -1. So if index is greater than 0, bigger than -1, we're going to go ahead and push it. So we're going to go add our key down to our key vector there. Or you know what I want to do is if it's not there, I want to add it. Excuse me. So we only want to add things that don't exist. And then I want to handle our key up. So when we're doing a key up, we want to remove the key from the key vector. So on key up, add event and listener. Then we're going to do the thing I said we were going to do, and we're going to remove it. One kind of subtle bug is if you don't check for index equals to -1 and you get an index -1, what'll happen is if you do the remove operation, it'll remove from the back, and you'll be really confused because random keys will start getting like random things from your list will start getting removed. So in JavaScript, what we can do is the splice method. So we say, okay, we want to splice this thing out of the array at this index, and we want to delete one thing. So yay, that's how we remove things from a list. So now we have this key vector that'll tell us what keys are being pressed at any given time, because then their presence in this list will be that. You know, one thing that can be helpful though is if we have like a convenience method. So we can say is key pressed, perhaps, and then we can give it a key code, and that's a string. And remember, those are like of the shape like, you know, key Q, for example, or arrow down. You know, those are what those codes look like. And we could make a big enum of them if you wanted. But now we can say, you know, hey, do we have this key code in our key vector? Then that can be super useful in your game logic. And you can do other cool stuff here too if you started keeping track of like was the key just is the key down is being held, or is the key just was keyed up? So you can do lots of really interesting stuff with key vectors like this. This just makes it a little easier to work with than trying to like put game logic into an event listener like this. So now with this, we can go and wire this into our main. So we want to handle input here. So let me go ahead and new up a keyboard here. So keyboard. And we'll new that keyboard up here in our init. New keyboard. And then here we can handle some input. So keyboard, let's say if keyboard dot is key pressed arrow right, we want to move the sprite to the right. So we'll say 100 pixels per second. We'll move it to the right if the key is pressed. So let's make sure that that's working real quick. And we will switch the screen over. So if I hit arrow right, we're in business. We're going 100 pixels to the right. Cool. Neat. So we can do the rest of the keys. Let's go and do that. So if that is pressed, we're going to go to the right. If the arrow left is pressed, we're going to go to the left. And if up and down are pressed, we're going to go up and down. Arrow up, arrow down, all around. So negative y is up, and positive y is down, I believe. So let's make sure that that works. So let's go switch over here. Cool. We can move him around. Now what's interesting here is he just keeps moving when our after we've released the key. So it makes me think that our key release logic isn't working. So like if I press a key down here, he just keeps moving and I'm not holding it. And that's not what I want. I don't want him to only move if my key is held down. So let's debug that. Let's go take a look. Let's look at this keyboard. So let's make sure that our key up logic is working. And I can already tell that this is wrong. So if we have a key in our key vector, we want to remove it on key up. So let's go take a look at that here in the browser. Let's see if that fixed it. Cool. Now our little robot only moves when we do the arrows. Cool. And just to review what we did there is we created a type called keyboard. We're keeping track of all the keys that are pressed. So when we get an event from the browser key down, we're going to go and add that key to the list. And then when we release the key, we're going to go take it out of that list. And then we made a little helper method here to help us out in our main here. So right when we're handling our code, our input. So that's not too bad. Keyboard is kind of like the easiest stuff to make happen. So there it is. So each frame we reset the velocity and then we set the velocity to what we want. Cool. So you can get real fancy with keyboard stuff. This is kind of like the 90% case. This is like, well, this will get you pretty far. Just like, is your key pressed? Sometimes you want to know the key down, like has a key happen to be pressed down this frame? And the way that you would do that is you keep track of a, keys down. We can maybe do that right now. So you might want to do that like if the key was just down and not being held down, you can do that like this. So you can do keys down, and then do the same kind of thing here. So what we'll do is we'll do the same kind of lookup here of the code so we can know if this key was just pushed this frame and push it into the key down. So like, is the key like just down? And what we wind up doing here is we'll have to clear that every frame. So at the end of the frame, we'll clear that list. So I'll just make an update here. Actually, maybe I'll make it clear. That is more clear. Oh, I have a typo here. I can already tell. So what we'll wind up doing here is we'll do this dot keys down dot length equals 0. This is kind of a cheap trick to clear an array really fast. So you can just say dot length equals 0, and that'll clear it. And then that kind of begs the question of like, was the key lifted up this frame? Like, did you take your finger off the key this frame? Let's do that same thing. So keys up, index of our key code, if index up is equal to -1. So this is like, we want to keep track of, do we have a key like this yet? So if so, then we want to push our key code in there. Cool. And then we'll do the same thing here and clear it every frame. And then we're going to want a helper for it. So is key up code. And this will tell us if this key was lifted up this frame. Whoops, I want keys up, index of code. And if we got one of them, which means the index is not -1, we can go ahead and do that. And we can do the same thing for keys down. Is key down. Very good. Cool. So let's go wire that up to our main real quick and see how that works. So at the end of our update, we're going to want to run this clear. So I'm going to run the keyboard clear, remember, because we need to clear that vector every frame. Otherwise, we will have keys from the last frame cluttering up our vector here. So what I can do then is I can say, like, maybe I wanted to wire this up to like a jump. So, is key down A, key A. And then I'll just, jump. I'll make a console log here. So we should be able to go and take a look at that in the browser, and then it will only fire on the frame that, like I hit, the A down. So it won't fire multiple times. So there's jump, jump, and if I can hold it down, it will fire every frame. Jump, 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 jump. Just like that. And then you could do the same thing for the up as well. So there we go. You got key events. Huzzah. Not too bad. So that's kind of like your bread and butter here for games. Like, and building a little helper here can get you pretty far. All right, let's move into maybe the next thing, which is infinitely harder, and that's pointers. Browser pointers suck. There's a new type. It used to suck more, but there's a new type now called pointer. because before you used to have like a mouse event and you had touch event, and then you'd have to like, you know, marry the two, or you know, work with multiple different event handlers and stuff. But now you can get this pointer event, which kind of combines all of them for you. So that's what we're going to use here. We're going to use the pointer event to help you out. So it's going to look and feel a lot like we did for the keyboard, but maybe a little different. So, okay, let's do pointers. So we're going to want to wire up our pointers kind of in a similar way, where we're going to listen to the browser's pointer events. But in this one specifically, I want to target the game canvas. Because I only really care about pointer events inside of the context of the canvas. You can certainly target other things, like you could do the document element if you wanted to track the pointer outside of the game canvas. And what do I mean by game canvas? Like, let's go take a look here real quick what I mean. It won't take long. So by game canvas, I mean like this blue rectangle, right? I don't want to track pointer events that are happening out here. I don't care about those. I only care about pointer events that are happening in here. So that's what I want to track. So I'm going to target my canvas element. And then in my canvas element, I want to listen to the different pointer events. So I want to have pointer down, I want pointer up, I want pointer move, and pointer cancel. So let's go through those real quick and then wire them up. So I'm gonna make a public handle. This is going to be the thing that handles our events. And I'm going to make it, actually, I'm going to make it a arrow function. That we'll do that in a second. But for our pointer down, we'll pass it handle. And we get all of our other events here. So we have pointer down, we have pointer, is it pointer up? Pointer move, and pointer cancel. So those are our events. Now there's a couple other things that you might want to do in addition to like wiring up the events here. We'll want to, and this kind of happens if you're on like a touch device. You'll want to set the touch action to none. Oh, because it'll want to do like panning and scrolling and pinching gestures. So touch action none will prevent the like the pinch to zoom stuff that you have happen on like an iPhone or whatever from happening, because that really interferes with your game. So touch action equals none. So that's a tip right there. You want to throw in touch action equals none just to prevent that that touch action from getting in your way, because there's those built-in gestures into the operating system of your of a phone or a touchscreen device. Just FYI, that is super helpful. So now we're going to do something similar to what we did with like the key vector, but it's going to be a little different. So pointers supports multiple pointers at once, depending on like your device. You might be able to support like, like, especially for like a touch, you might be able to support like multiple, touch points at once. So what we're going to wind up doing is I'm going to create a map that will map the ID of, which is a number, the ID of the pointer to like the coordinate of the pointer. So I'm just going to use, XY in a tuple, kind of like that. So that's one way I'm going to do it. And then the other thing that is useful to keep track of is is the current pointer down. So I'm going to do the same thing here, but I'm going to track like a Boolean. So with using the map type here, because it's got some convenient properties. So, okay, so now we're going to do the handle. So when we're handling one of these many pointer events, we're going to want to prevent the browser from doing its default thing inside. And keep in mind, this is inside of that game rectangle, so we want to be in control of it. So this may or may not be the right thing to do in your situation. Like in your situation, you might want the default, especially if you have like examples of where you want the default is like if you have HTML UI, you want that default. So you want like the checkboxes in HTML to work. You want inputs to work, all of the default stuff to work. But in our case, inside the canvas, I don't want that to happen. So cool. So now we're going to go and I'm going to switch on the event type. We're going to go case, pointer down, break. So on pointer down, I'm going to want to say, okay, so we have this current frame down. We're going to want to set the pointer. So we have a unique pointer ID here on these events for pointer types, which is super useful because you can disambiguate different touches. So like if you have like a touch screen, you can be like 1, 2, 3, 4, 5, and you get those IDs back. So I want to say, okay, well, the pointer is down. I also want to, set the current frame or the current position. So we'll get that pointer ID again. And then in here, there's different XYs we can use. There's like client XY, there's like screen XY. What we want is offset XY. And this is the offset from the target element that we're listening to, so which is the canvas. Because we want that position from that corner, that top left corner here. We want this position to be 0, 0. And if we did like screen or client, we'd be getting positions out in the DOM. So this would not be 0, 0, this top left corner of the blue rectangle. So offset X is what we want in this case. You can do, depending on what you're doing though, you might want different stuff. So, just keep in mind to look those up because there's 3 different sets. In our case, we want offset because we care about the offset inside of our canvas, remember. So bang, so we got pointer down handled. So after pointer down, we want to do pointer up maybe. So on pointer up, I'm going to say, well, this is false. Our current pointer is not down anymore. And then, and here I want to go ahead and delete the pointer since we don't have a position anymore because we lifted the pointer up. So when the pointer's up, we're going to delete it. And then when the pointer's down, we're going to add it. The other thing that I want to do is pointer move. So let's do pointer move real quick. It's going to be very similar to pointer down. So I want to do current frame position. I want to do that. But I don't want to do pointer down because that's not like a pointer down. That's not like the moment that it goes down. I want it to be like separate. So this will update us whenever we move. This will update us whenever we have the pointer down event. So like when the pointer goes down, we flag it as down. When we lift up the pointer is pointer up is false. That way we can keep track of the state of a particular pointer. And then as the pointer moves, we can set its position as it moves. And then I'm going to do the pointer cancel as well, which I forget exactly where it comes into play, but it's basically the same as like pointer up in our situation. We want to cancel it out of the we want to cancel it out of the position. I don't want to necessarily set the up and down state, but I don't want to update the position in this case in a pointer cancel. Let's actually go look up pointer cancel because I don't remember what it's about. Let's see, pointer cancel event. What's that about? All right, so it's fired if the browser determines there is unlikely to be any more pointer events, or after the pointer down event is fired, the pointer is then used to manipulate the viewport by panning, zooming, or scrolling. Okay, so that's when it decides that, oh, maybe you didn't want to do that. So maybe we do want to set it to false in the pointer cancel. So I'm going to do that. Sure, I'll be wrong if that's the case. Cool. So awesome. Now we have all of our kind of very similar pattern to what we did with the keyboard over here, where we're keeping track of things kind of in a data structure. And then we're going to add some convenience methods here so that we can query the pointer. So let's do that. So one convenience method that you might want is like, is the pointer down? And I think we can do like an optional ID. So if you don't provide one, we're just going to say you mean the first one. So just like your primary pointer. So like in my case, it would be my mouse. So we'll say, is the pointer down? We'll default to the, the primary pointer, which is 0. So if this dot pointer, let's see, what is it? Current frame down has ID, then we can say return this dot current frame down get ID. Cool. Otherwise false. Cool. So then we can get pointer down. So let's make sure that that works before we go too much further. So let's add if pointer. Ooh, you know what? I'm gonna have to new that up. So let's go ahead and do that. So let's do let pointers pull that in, new that up here in our init, new that up, and then I want to target the canvas, and then I can ask, okay, if pointer is pointer down, and we'll do the default one, which is 0, and I'll do console.log pointer down. Cool. So let's give that a shot. So let's go over here to the browser again, and oh, it's not working. Okay, so we got something wrong. So let's go take a look. Let's debug. Okay, so is pointer down, pointers. All right, we have current frame down, constructor, we're listening to the canvas, we're handling stuff, we're setting stuff, and pointer down, we're true. Is pointer down if we have ID, we're going to go current frame down, we're going to get the idea. Okay, so that should be working. Let's open up the debugger here and take a look. Okay, so let's make sure that our events are even firing. So click. Okay, so that's a good sign. We have current frame down. We've got 1 equals false. Oh, so we have a pointer ID of 1. So maybe that's why. All right, let me try refreshing here. Yeah, so it is pointer ID 1. Huh, I thought 0 was always the primary, so that news to me. So, all right, so we're gonna have to fix that. So how do we know what the primary is? So let's figure that out. What we could do is grab the first thing we find, or the lowest ID that we find. Let's see. No. Find primary pointer web API. Oh, there's a primary property. Oh, there's a primary property off the event, so we can probably use that. Event is primary. So what we could do is we could set 0 to be the primary, and then that thing would work all the time. So maybe we do that. So here's what I did, is I moved the is primary up to the top here. And then we're going to default to the primary ID if we don't have one. So we're going to go ahead and give this a shot. And go ahead and refresh this. Hey, pointer down. Look at that. So one thing that's interesting is, that actually makes sense, because the pointer down is happening we're checking, is the pointer down every frame? Okay, that does make sense. Cool. We can do the same thing for pointer up. Is pointer up. We'll do the same thing. Primary ID. If stack current frame down has ID. So if it doesn't have the ID, we know that we can return true. Because if we don't have the ID, we know that it's up. So if it's not down, it's up. Otherwise, we can return this dot current frame down. Not get ID. So that should give us the pointer up. So let's go ahead and check if that works. So we'll do pointer up. And is pointer up. Give that a go. Cool. So it's up continuously. Let's see if I can zoom in on that. So pointer's up, down, up, down, up. Awesome. So up and down states are working. Now we want to make sure that we can get at the current location. So we'll switch that over. Let's go to pointers. So if we have this dot current frame position has ID, we're going to go ahead and return it. Otherwise, what I think I'm going to do is I'm going to return zeros, maybe, if we don't have it. Otherwise, we could return like -1 or maybe false to indicate, whatever sentinel you want to use to indicate that there's not like a thing there. So let's go here and grab the current location. Get current point location. We're just going to log that out. I'm going to comment these out for now, just so we don't have extra stuff in our logs. Cool. So let's go take a look at that. So we are at location 0. And if I move around, remember the impetus for using offset X and offset Y. That means this upper left corner is 0. So we get pretty close to that here if I get infinitesimally close. And then if I keep looking over here, let me move this to the right. We get to the other corner, and then we're 600 by 400. So there you go. So now you have the XY location here in your game, and you might want to like click on stuff, and you might want to click and drag. You can do all those things now because you can say like, okay, is the pointer down? And then am I moving after pointer down? So you can do like drag type stuff and pointer up and that kind of thing. So that's kind of your basics there for doing pointer input. Let's see, is there anything I want to talk about else about pointer input? I think that might be the big, that's the biggies. So reviewing kind of the strategy so far. So in the keyboard, we're doing the same kind of thing. We're keeping track in a data structure, you know, that we can pull every frame. That's hard to do. You know, pulling every frame is hard to do when you have event listeners like this. So really stashing those away in here with some convenience methods can really work a little better for you. Like when you're doing like game loop type logic like this, it's a little easier to, you say, okay, in this frame, am I in this situation? Cool, yes or no, let's do some game logic. You know, oop, I didn't switch the code. You know, yeah, same thing applies. We're keeping track. You know, we have these event listeners. They are hard to use like in situ. Like if I were in here, like using an event listener in here would be really hard to do. I want something I can pull. So that's what this is all about. So pointers are the same deal. So I'm keeping track of my current state. I'm using the event listeners in the browser, and I'm squirreling that information away in a way I can pull later for information. So far, so good. Now, the last thing I want to talk about in terms of input is gamepads. Gamepads are pretty cool. So for a long time, there's been, so here's an Xbox controller. For a long time, the Gamepad API has been a thing, and it's kind of like a sleeper. Like a lot of people don't know that this exists, but there's totally a Gamepad API that exists in the browser, so you can use gamepads themselves. There's even like experimental support for like haptic. You're gonna have to write some code because like some of this works in Chrome, like this one. You need to use the vibration actuator in Chrome, and then haptic actuator is only in Firefox. So you're gonna have to write some code to, you know, work around the differences in gamepads. But otherwise, the Gamepad API is very much kind of in the vein that we want, and it's already kind of pre-built in the way that we want, where like in here we wanted to do the polling operation to observe the state, and in the Gamepad API we can just do that right off the bat, so that makes it a little easier. It does have some quirks, so we'll talk about those as we get through it, but let's go ahead and work on gamepads. So let's export class gamepads. With gamepads, the Gamepad API has a couple of input events. There's like two basic ones that you're going to need, and that's connect and disconnect. So we'll wire those up here real quick. So we'll grab window, add event listener. I think it's Gamepad connected. So when we connect, we're going to do something, and then window, add event listener, Gamepad disconnected, and then we're going to do something about that. But other than that, it's going to be like polling the gamepads themselves. So what we'll do is we'll get the gamepad out of the event, and then we can actually take a look at this type. So there's just like a whole gamepad here that we can that we can look at. And it's got axes, which are like your joysticks. It's got buttons. You got whether or not it's connected. And it's got a unique ID. It's got an index. The index and the ID are different. So the index is like where it is inside of the browser list, and the ID is like the manufacturer of the gamepad. So you can like, oh, is this a Xbox Pro controller or whatever? Then do this or something if you needed to. So I'm gonna go ahead and log out the connected event just so we can see it happen, and then we'll log out the gamepad. I'm gonna do that thing I do, which is abuse the map. So I'm gonna keep track of gamepads in a map. We're gonna map them based on their index, which is a number, and then we're gonna have gamepad. There we go. So we're gonna go ahead and do this gamepads, set our game. I want that to be a gamepad, not game. Gamepad dot index, not ID. Index is the thing that we're going to want to retrieve them later, and then we're going to want to set the gamepad. So that's our connected. Our disconnected is going to look very similar. We're going to grab the gamepad here. I'm going to go ahead and log disconnected. I'm using inconsistent quotes. Oh, and I'm logging out the type up there. Goodness gracious. And I'm going to go ahead and delete the index here. So we don't need it anymore. Cool. So, and I'm missing a comment. Goodness gracious. I'm having a hard time typing today. So let's test that out. Let's wire that up so that we can see the gamepads and see if they're working okay. So I'm going to go ahead and go up here next to my other stuff. Gamepads. We'll new that up. And then we should be able to see the gamepads connect and disconnect. So let's go take a look at that. So I'm going to grab my Xbox controller right here. Xbox controller, and then it's currently not plugged in. So let's go over here to the console. Oh, you know what? Let's get rid of those logs because that's just not helpful right now. There we go. No more logs. All right. So not connected. We're gonna plug it in and unplug some of my other stuff here. Plug that in, and I should get it connected theoretically. There it is. Oh, I got it connected and I disconnected. All right, let's try it one more time. Ooh, that's interesting. I've never seen that before where it connects and disconnects. Interesting. Makes me feel like I did something wrong. Yeah, it is pretty cool that this is part of the browser API. Oh, you know what I did? Is I did gamepad connected twice. That's why I'm confused. Yeah, it's very cool that this is part of the browser API, that this is just a thing that exists. All right, let's try that one more time. All right, plugging it in. Refreshing. Plugging it in one more time. There we go. I've got a gamepad that's connected. Slick. Okay. So again, there's that ID I was telling you about, which gives you like the name of it. Oh, from memory, it doesn't work with Bluetooth ones like PS5, I think. Oh, interesting. Maybe not. I know that it doesn't work. From earlier today, I was trying to get the Pro Switch controller to work, and it's got some goofiness, the Switch controller. So I would 100% believe that the PS5 one wouldn't work. So your mileage may vary. You might have to write custom code based on like the ID of the controller to make different things work. Like this one has some problems. Like it like oscillates through the buttons I know there's some like third-party drivers out there, buyer beware there, to make these work, but I couldn't get the Switch controller to work. So it's not everything that glitters is gold, I guess, in the Gamepad API. So yeah, thanks for calling that out. It could be the case that doesn't work super well. Yeah. I know Steam has their own custom setup for these Pro Switch controllers. So they built their own driver, I think, for them to make them work. So bummer, dude. Yeah. Okay. So gamepads, they're awesome. They work sometimes. So let's dig into the gamepad, making the gamepads work. So we've got this wired up to the events for connect and disconnect. Now we're gonna want to read like individual bits and bobs of information off of the gamepad, and I don't want to write this out, so I have a big enum that's gonna have all of the different axes and buttons. Let's just format this real quick. So there's the face buttons. You got your bumpers, you got your start and select, you got your D-pads, and you got the left stick click, when you press in the stick, the right stick click. And then you got your axes. And this is not all of them. This is like your standard controller, like Xbox controller I got. So your mileage may vary with the enum, so just keep that in mind. But that way you can use this to get at the different bits and bobs here on the controller. So oh, you know what? I'm not showing code anymore. So I didn't code anything. I copy pasted an enum full of buttons and axes here. But if we look over here, we can dig into the actual data structure in here. But so these are, you can tell there's some drift. It's the left stick, right stick, and all my buttons. All right, maybe I'll be better at Windows today. So we're gonna want to read those out. We're gonna want to get at a gamepad and read those specific things out. So how do we want to do that? Well, for the Gamepad API, it is built to be pulled. So you do need to pull it every frame to get a snapshot. I believe this is the case in Chrome. You have to pull. I think in Firefox you might not have to. This object might just be the state, the live state. But in any case, in order to work cross-browser, if that's not true anymore, you do need to pull. So you need to grab the gamepads off of, I can't spell, off the navigator. So get gamepads. So once we've got our gamepads, what we can do is for const index gamepad of this.gamepads.entries, slick trick with the map, you can enumerate through the keys and the values. We can go ahead and rip through and update our representation, our data structure of our gamepads. So I'm going to call this something else. I'm going to call this gamepads snapshot. So we're going to go through and get our new gamepad from our snapshot from an index that we know is connected. So remember we grabbed all the things that were connected. We're going to go ahead and grab that snapshot, and then we're going to go ahead and add some defense here, because could be something weird happens. But then we're going to go ahead and update our index here. So I can either, why don't I just set it? So I'll set index here, and we'll set our gamepad. Cool. Now reading out of that gamepad kind of sucks, that native gamepad. So I'm going to make my own gamepad type that will help us read out the information. So I think I'm gonna call this is gonna be, we can call that gamepad. So what I'm gonna do is make a constructor here to wrap the native gamepad object, because it kind of is hard to work with. And then I'm going to disambiguate between my gamepad and the built-in gamepad with my type. And now because I named it a new one in the file, I've actually shadowed this name here. So we're now talking about my gamepad, not the built-in one. So that's why I'm using this global this here to disambiguate. So I'm gonna go ahead and add a is pressed. I'm gonna do is button pressed. So same kind of thing we did for keys. I'm gonna have my buttons enum up here. The different IDs of the buttons here. So I can go ahead and go native, this dot native. I gotta make this public. This dot native gamepad buttons button pressed if it's pressed. I'll go ahead and do that, and then this might not be available to us, so I'm just going to default it to false. So if I can't find the button that if I can't find the droid that we're looking for, we're going to just say that it's false by default. I'm going to do get button value, because buttons can also have values. They also are buttons that are just digital states, like up or down. They'll just be 0 or 1, but some like a trigger might be between might be 0.1, 0.2, 0.3, 0.5, that kind of thing. So we'll do the same thing, value, and then if that doesn't exist, we'll just say it's 0. So cool. I'm gonna make a get left stick. So we'll return a tuple here with x and y. Const x equals this native gamepad dot axes, then axes left stick x. And then if that's, if it doesn't know what we're talking about, just say it's 0. Oops. We'll just say it's 0. And then we'll do the next one. This is a different keyboard than I'm used to. We'll do y, left stick y. And if we don't know what we're talking about, we'll just say it's 0. And they'll say, okay, we'll return out here. Am I working on a game of my own? Not at the moment, but I have some ideas. I've fallen into the classic developer trap of working on a game engine and not building a game. But I make at least one game a year through game jams and stuff. But I have a couple ideas, and my partner wants a game for their birthday, so I'll probably be making a game for their birthday. They like word puzzles, so that might be word puzzle related. But yeah, I'm not building anything at the moment, but I do make at least one game a year, sometimes more. One thing to keep in mind with the Gamepad API is, or gamepads in general, like we were talking about, is that these axes are just me not touching them right now. They're off 0. So you're gonna want to do a little filtering here, and this is the value that I'm using in Excalibur, 0.5. It seems to work okay. So if if we're greater than 0.5 off of 0, then we're going to return the x. Otherwise, we're going to return 0. Like, no joke, that's what I do. It seems to work okay. You know, your mileage may vary. That's my favorite word today, or my favorite phrase. But that seems to work okay. For like filtering out like off 0, like stick shift a little bit. I'm gonna do the right stick here real quick. And it should be pretty quick. Same deal. Look at that. Huzzah. So now we need to refactor this so that it can do our handle our new type. So I can give it, since we're wrapping the built-in type, we can just do that. We can do that. I think that might be it. Let's see. I think the only thing I want to do is like a little helper to get at a gamepad that like in a friendly way. So what I mean by that is if I want to get like a gamepad that doesn't exist, I want to return a default that won't break, like won't bomb. So like if I ask for a gamepad 5 or I ask for a gamepad like 99 that I don't have plugged in, I want to be able to handle that. So I want to get at my gamepads here in a safe way. So I'm going to make a get. So I can get at a gamepad. So we're going to do something about it. Otherwise, we're going to return gamepad. And I had to cast it there because it's possibly doesn't exist. It's possibly undefined. So here's where we're going to handle that possibly undefined thing. I'm going to make one. So if you ask for one, I'm going to make one. But I'm going to create an empty one that will give us like something safe. So what I mean by that is I'll just create an empty one here that's just like empty. It's got no buttons, no axes. It's kind of like a null object. You know, jury's out if this is a good idea. This is just what I do. This just makes it easy to get at stuff and not have to like put a lot of guards in your code to like guard against nulls. But this is maybe a bad idea, but maybe a good idea. Who knows? So now we can play around with gamepad input, which is awesome. So let's go play around with gamepad input. Let's go back here in main. I'm going to keep the arrow keys alone here, but I want to do some fun stuff with the gamepad. So let's go ahead and wire up our gamepads, and we already did. Okay, good. I'm going to get at our first player. Gamepads get 0, so that's going to be our first player. So if our gamepad, our first player, get left stick, 0 is greater than 0. So I'm pointing to the right. Remember the sticks are from -1 to 1. So I want to do sprite velocity x equals 100. So let's start with that. See if that works. I'll switch code. Yay! Okay, so that works. Doesn't stop, but if the stick is greater than 0, it just keeps going. All right, so let's go back here. All right, so left stick is greater than 0. You know, I want to make this more variable. So I actually want to say, if this is greater than 0, I want to grab a value out of here and then multiply it by the amount. So then we get a little more fidelity in our speed. So let's grab amount of the left stick here and multiply it. Okay, let's try that. What's interesting here is my left stick is never turning back to 0. Makes me feel like I broke something again. So let's take a look. Move over. Let's take a look. Okay, so left stick. Okay, left stick is all the way over, basically. Okay, so I am not pressing the left stick anymore, so it should be 0 now. Oh, you know what? It is. I figured it out. It's because I didn't do the thing I said I was going to do, and we need to pull the gamepads every frame. So let's do that. Cool. So we're going to pull the gamepads every frame, and there we go. All right. So now I can move the stick a little bit, or a lot of it. Very cool. All right. So there we go. Debugging on the fly. Live coding. It's such a joy. All right. So let's do the same thing for going to the left. So if we're going to the left, we're going to... actually, we can do this because it'll be a negative number. So we can do amount times 100, and that'll be, if we're going to the left, we're gonna do that. So let's give that a shot. Oh, look at that. And then we can do like a little bit, and we can do a lot of it. Very cool. All right, so let's do the up and down. Ooh, that's not what I wanted. There we go. Okay, left stick, the Y coordinate. So if Y is greater than 0, that means we're going down. So our sprite velocity Y is positive. If our Y coordinate is less than 0, that means we're going up, theoretically, and that should do it. So let's go take a look at that. See if that goes up, down. Look at that. I can swirl the stick around, and it's working. Pretty slick. Nice. Very nice. We can try doing like a just like a button press. So like if first player dot get button value. Let's do D-pad buttons. D-pad right. Oh, did I not return a value out of here? Oh, I didn't. Or this one. That's what you get for live coding. Cool. So if our value is greater than 1, you know what we can do is we can do is button pressed, because that's for the D-pad, that's all we got. So if the D-pad right is pressed, we want to go sprite velocity x equals 100. So we'll do that one real quick just to kind of prove that that works. And there we go. Oh, is that working? There it is. D-pad right. That's D-pad right. I'll prove it. D-pad right. Cool. So that's working. Very slick. So as you can probably tell, this kind of leads into my next topic that I want to talk about. As you can probably tell, this is getting pretty gross. Like all of this input logic that we have to manage, like this stuff looks pretty ugly. So one thing that I like to do with these is there's a pattern called input mapping. Let's see if I have it up here. So I've pre-written this, but there's a pattern called input mapping, which is super useful when you want to do like accessibility. So like say you want to map like a particular input to a particular command. And if you do that, you kind of decouple your input from your game logic. So right now our input is tightly coupled to our game logic, and it makes it hard to refactor. So what I want to show you is like the joys of input mapping. So let's make an input mapper and show you what I mean. You know, if you ever remember like those screens that you see like in games, like where you want to like change your key controls, this is like, this will let you do that. But it also, you don't have to expose this at all. This will also just make it like way easier for you to just manage your own code. Oh, I'm gonna refactor this real quick. We're gonna add pointers in there. Oh, parcel crashed. That's okay. Cool. So got an input mapper here. And what I want to do is I want to decouple. Remember, I want to decouple my logic of my commands in my game from my input. So what I'm going to wind up doing here is I'm going to create a list of like move right, and this, you know, in a more sophisticated game, these would be like way more complicated potentially. So like you might have very complicated commands that you might issue. So you might move right, move left. And here it's kind of trivial, but trust me, like in other games, like this can get really complicated. So we're gonna move up. That's the negative y, and we're gonna move down. It's positive y. Cool. So I now have my commands that are possible to issue to my character in my game. And then I want to map those to my inputs that are possible. So what you can do now, sprite inputs, or was it input mapper? Yeah, input mapper. So with this type now, I can do things like this, where I grab, like, let's say I want to re-implement that keyboard stuff I was doing. So I want to say keyboard, when keyboard is pressed, key is pressed, you know, arrow right. So when arrow right is pressed, I want to move right. Bam, look at that. Now my input is decoupled from my game logic. So I might have a class that has all of these in here, but now I can implement like any arbitrary like input mapping to a command, which I don't know if this is blowing your mind yet, but like this is super cool. This is like a thing that saves you so much time. And then you don't like, then refactoring is easy. Like if you decide that you're like, you know what, I don't like how this key combo works, you can change it like super easy. And then the other cool thing here is you can do like more than just one type of input. So you can take advantage of all of the different inputs that we were talking about today. So now I can grab like the gamepads can get that first character one, and I could say, is button pressed, buttons, D-pad right. And guess what? I can move right. Isn't that wild? This is super slick. This is the way. I'm not saying it's the way, but it's so totally the way. And then, you know, if you wanted to, like on your accessibility screen, you could expose this functionality so that you could use this, you know, so that people that maybe are differently abled are able to remap the commands in your game and still play your game. So there's that, and then we can go and try that out here. So this input mapper, it's basically just a fancy way of doing that mapping with my favorite data structure, the map. Who would have thought? And then all you need to do is call execute on it. So what we'll wind up doing here is, you know, all of this junk here that we had in here already, we can delete it and then execute. Cool. So then we can go and check that out, and hopefully it works. Oh, you know what? Parcel died. Let's restart parcel. There we go. Cool. So now I can do this. I can do my keyboard keys. And all of that is just mapped and run right here. It's just super slick. So all of that logic is encapsulated in our mapper. And in fact, we can get even fancier with it. This can be, you can pass an output out of the mapper left-hand side into the right-hand side. So for that case that we were interested in where we had the analog stick, we can make that work. So so let's refactor this to take an amount, and I'll make the number. Number. So we can make these ones work too, because if it's pressed, we can just return 1, and if it's not pressed, it's 0. So we can just make these work just out of the box, since we're at Boolean states are easy to deal with in this situation. Same with these ones, so we'll just refactor that real quick and just rip right through these. And then we can do our input mapper on our gamepad analog stick. Gamepads. And then we can get left stick. Get that 0. That's greater than 0. We're going to return that left stick. This looks a little gross. Normally I wouldn't write this all in one line other than to show how cool it is. So, oh, you know what I also forgot to do? Multiply our amounts. Cool. So, just so that you don't have to watch me type all of these out, I'm just gonna go ahead and use my cheat sheet. And I've already changed variables. There we go. Cool. And you'll note in here that I'm doing absolute value because I'm not using the negative in here. But you could switch that around in here if you wanted. Since I'm making amount always be positive in here. So we can go take a look at that. Let's go open up the browser here and try it out. And just so I can prove I'm not lying. So there's the analog stick, you know, there's the D-pad, and then we can hit the keys. I'm just gonna show this, and I'm gonna hit my keyboard. I was focused on OBS there, and hit my keys. Ooh. Or not. My keys aren't working. Left and right are working though. My arrow up and down aren't working. Let's try that one more time. Oh, there we go. I must have messed it up. There we go. There's our up and down, our gamepad, and our D-pad. Slick. Very slick. Cool. So that was input. And we really scratched the surface on some of these. Like you can really get fancier than this. Like specifically with pointers. Pointers get like mega complicated, mega fast. Like if you want to see some really gross, complicated stuff, crack open how Excalibur does it. It's pretty wild. It probably could be refactored now because a lot of it was using like a lot of fallbacks and a lot of fallbacks to like mouse event or touch event to support older browsers. But nowadays, like the pointer event is pretty well supported. So there's actually probably a lot of code we could get rid of. But also like things I didn't cover in here is like the mouse wheel in here, or pointer clicks. Like you know, like the mouse has buttons on it. So we didn't even talk about those. We can listen to different buttons on the pointers and stuff. Really, you can get quite fancy with it. But yeah, but I think that is gonna wrap it. We are at an hour and a half again. That just flew on by. Well, I hope y'all enjoyed the Monday night, Sunday night stream. But I think I might call it for that for today. But really appreciate y'all showing up and watching. All a handful of you. I appreciate it. Yeah. Well, thanks. Yeah, I like the mapper too. This is the thing that blew my mind. You know, when I figured it out. It just really helps. Really like make that logic super crisp and super nice. But yeah. Well, folks, I think we're gonna call it there. And thanks again. Video will be up probably in a few days on YouTube, but I appreciate it. Thanks. Bye-bye.